A ver.
Well, I hope that you are having a wonderful day. Well, I'm going to explain how to solve an homogeneous system in matrix. Well, first, we have to understand what is an homogeneous system. That is a system of linear equations where all the constant terms are zero. For example, here we have the example ax plus by minus cs is equal to zero. The the values, all the values, if are sum at if added or rested, it will be almost zero. Well, we have an example here. X plus y plus s is equal to 0, minus 6x plus 3y plus s is equal to 0, and 4x minus 5y plus 3 is equal to 0. The first step is identify what data is the system what data the system are giving us. Well, the second step is choose a method. In this case, we choose a Gauss Jordan method. And to start, we write the coefficients of the variables inside the matrix, including the results of the sum of the rest in the equation. Well, the third step is going to do a series of operations to reduce the matrix, that it's only its main diagonal with coefficients with 1 will remain, and all other coefficients will be 0. This, all of these are going to be 1, and all of this and this are going to be 0. And for better organization, it is the file 1, the file 2, and the file 3. Well, the first step to start to multiplying, dividing, and all of this is multiply the file 1 plus the file 2, and the result is going to be right in the second file. For example, the 6 is multiplying to 1, and 1 times 6 is equal to 6, and 6 minus 6 is equal to 0. And it's the result that is right in here. And it's the same version with the 1, with the second column. 6 times 1 is equal to 6, plus 3 is equal to 9. And it's the same. But um, the result here, it's necessary to be 0. And here it's necessary to be 0, 2. Sorry. It's necessary to be 0 here, 2. Here 2, and here. Well, it could be a large procedure, but you are going to search. You are searching that the diagonal are 1. Well, to find the one that we are searching, it's necessary to multiply to 1 over 9 the f2, and the result will be put in the f2. The result is going to be 1. Well, it's the same procedure. The same procedure at final, the result is equal to the diagonal that we have mentioned, and the rest of numbers equal to 0. Well, what we can conclude with this data? We can conclude that these results, the 3 that are here, it are the x, the y, and z. And if it is 0, the result of the letter is 0. And if you have a question of this, well, you can go to the original equations and substitute the letters by the 0 that we had. 0 plus 0 plus 0 is equal to 0, minus 6 times 0, plus 3 times 0, plus 0 is equal to 0. And it's the same for the last equation. Well, with this, we can conclude that our result is